Today we are going to discuss about the sensors and measurement systems. First we will discuss about the functional blocks of a measurement system. What is measurement? It is development in science and technology, comparing an unknown quantity with a predefined standard, and that is quantify an event or thing. What is instrumentation? Instrumentation deals with the measurement and control of various non-electrical parameters. The electrical parameters are voltage, current, resistor, capacitor, inductor, impedance, etc. Non-electrical parameters are temperature, pressure, flow, level, etc. Measure, monitor, analyze, control and record various parameters. Standards of measurements. When we measure, we use a measuring tool to compare some dimension of an object to a standard. These are some of the tools for measurement. These are the units in measurement system: length, volume, mass, temperature. What are the purpose of measurement? To understand an event or operation, to monitor an event or operation, to control an event or operation, to collect data for future analysis, to validate an engineering design. The functional blocks of a measurement system. Figure shows the functional blocks of a measurement system. It consists of three basic functional blocks. One is sensing element, another one signal conditioner, third functional block is data presenting device. All these functional blocks require power supply and input is given to the sensing element. Input here physical quantity to be measured, example flow, level, temperature, pressure, any other physical quantity which can be measured is given to the sensing element. Here sensing element is a sensor or transducer. The sensor or a transducer senses the physical quantity and that output is directly given to the signal conditioner. Signal conditioner convert the input of signal into the required form. Output of transducer to the convenient form for further processing. The functions of signal conditioner are linearization, demodulation, filtering, amplification and analog to digital conversion. Signal conditioner output is given to data presenting device. Mostly the data presenting devices are pointer, recorder, LCD, LED, printer, monitor, etc. The data presenting device used to present the measured quantity to the observer. Some of the examples of sensing device: microphone which convert the sound energy into electrical energy. Data presenting device examples are given here, and again shows the functional elements of a measurement system. This is the detailed view of a functional elements of measurement system. Consists of 5 functional elements: primary sensing element, variable conversion element, variable manipulation element, data transmission element, data presentation element. Primary sensing element is also known as sensor. Basically, transducers are used as a primary sensing element. Here the physical quantities such as temperature, pressure are sensed and then converted into analog signals. Variable conversion element used to convert the output of primary sensing element into a suitable form without changing the information. These are called secondary transducers. Third one is variable manipulation element. The output of transducer may be electrical signal. Example voltage, current or other electrical parameters. Here the manipulation means change in numerical value of the signal. This element is used to convert the signal into a suitable range. Fourth part is data transmission elements. Sometimes it is not possible to give direct readout or the quality at a particular place. For example, measurement of temperature in the furnace. In such a case, the data should transfer from one place to another place through channel, which is known as data transmission element. Typically, transmission paths are pneumatic pipes, electrical cables or radio links. When radio link is used, the electronic instrumentation system is called as telemetry systems. Finally, data presentation or controlling element. The output is recorded or given to the controller to perform the action. It performs different functions like indicating, recording or controlling. This picture shows the example for a five functional blocks of a measurement system. Here example is given as a Bourdon tube pressure gauge, and this Bourdon tube pressure gauge which indicates the basic five elements of a functional blocks of a measurement system: primary sensing element, variable conversion element, data transmission element, variable manipulation element, and data presentation element. You can see the Bourdon tube act as a primary sensing element. Here one end is open, the other end is closed, sealed. So the pressure to be measured is directly applied to the open end of the Bourdon tube. So primary sensing element, the C-type Bourdon tube, senses the pressure, and it is also act as a variable conversion element which used to convert the pressure into pressure into output. Data transmission element, here mechanical linkages which are connected to the other end of the Bourdon tube, which are considered here as data transmission element, which used to display the data over the pointer and scale arrangement. And the variable manipulation element here consider are gearing mechanisms. There is a pinion and gear arrangement with the pointer which used to manipulate the data, and pointer and scale are considered as a data presentation element which used to display the data over the scale. Next we will discuss about the difference between sensors and transducers. Sensor is a device which responds to physical stimulus. Transducer is a device which converts one form of energy to another. And also we can say non-electrical quantity is converted to electrical quantity. Sensing element is sensor or detector, and transduction element, sensor is a part of the transducer. This picture shows a device that receives and responds to a signal or stimulus. In the earlier days, person's eyes are considered as a sensor and hands are considered as the actuator. So to control the level of water in a tank considered here, there is a tank containing an inlet pipe and an outlet pipe, and water is flowing. If you want to maintain or monitor the water level, eye is the sensor, and if you want to control the water level at a particular position, he can close the valves manually. This is called a actuator. What is a sensor? A sensor is a device which converts physical quantity into electrical form or convert non-electrical quantities into electrical equivalent. Here non-electrical physical quantity output is given to sensor, and output is given to electrical equivalent form. What is a transducer? How it is different from a sensor? A sensor used in conjunction with signal conditioning is called as a transducer. Signal conditioning circuit performs amplification, filtering, frequency response matching, grounding or isolation. So transducer is a combination of sensor plus signal conditioning circuit. This is again one example for a sensor and a transducer. Input device is microphone, and output is given to controllers or system where it gets amplified, and output is given to loudspeaker. So the microphone convert the electrical signal into sound signal. All the transducers are sensors, but all the sensors are not the transducers. The physical quantity can be temperature, pressure, force, motion and displacement, humidity, light flow, etc. This picture shows some of the examples of sensors used for various purposes: RTD, thermocouple, piezoelectric transducers, PIR sensor, IR sensor, LDR, gas sensor, color sensor, touch sensor, humidity sensor, moisture sensor, ultrasonic sensors are used for measurement of various parameters. And this one shows the examples of transducers and sensors used in industrial applications: pressure transducer, temperature transducer, flow transducer, humidity transducer, level transducer, vibration transducer are some of the examples. As per the definition of the sensor, it is a physical device that is useful for measuring the changes in surroundings after measuring their physical quantities and transforming them into a signal that can be easily read by the users. Examples: motion sensors applied in home security system as well as automation door systems. Photosensor sensors changes in infrared or ultraviolet light. Accelerometer sensors are utilized in the mobile to detect screen rotations. Next we will discuss about what are the units and standards. Units means standard measure of each kind of physical quantity. The result of a measurement of physical quantity must be defined both in kind and magnitude. There are two types of units: fundamental units and derived units. Fundamental units are units which are fundamental to most other physical quantities. Example: length, mass, time, electric current, temperature and luminous intensity. Derived units: all other units which can be expressed in terms of fundamental units are called derived units. Example: velocity, which is distance per time. These are examples of some SI units. There are 6 fundamental units and 27 derived units. There are different systems of units. They are called FBS system, CGS system, MKS system, rationalized MKSA systems. What do you mean by standard of measurement? The physical representation of a unit of measurement is called standard. Classification of standards: these standards are classified by their function as international standard, primary standard, secondary standard and working standards. International standards. International standards are standards accepted internationally. It is maintained by International Bureau of Weights and Measures near Paris. They are not available for the common user for the purpose of calibration or comparison. It represents the units of measurement which are closest to the possible accuracy attainable with present day technological and scientific methods. Primary standard maintained by National Standard Laboratory in different parts of the world. In India, National Physical Laboratory, which is at New Delhi, is responsible for maintaining primary standards. These are not available for use outside the national laboratories. The main function of primary standards is the verification and calibration of secondary standard. Secondary standards are basic reference standards available in different laboratories. It is used in industrial measurement laboratories. It is easily accessible to all measurement engineers. Finally, working standard. It is used to check and calibrate general laboratory instruments. Classification of transducers. Transducers are classified in 3 different ways: based on the physical effect employed, based on the physical quantity they convert, based on source of energy for their output. Based on physical effect employed means under this category the transducers are called physical quantity applied as measured to the transducer causes some of the physical changes in its element. By this physical effect, the transducer convert physical quantity into electrical quantity. Example: change in temperature to be measured causes variation of resistance. So these are all called variation of change in resistance, change in inductance, change in capacitance, piezoelectric effect, magnetostrictive effect, elastic effect, Hall effect are some of the examples of this type of transducers.